welcome to our JavaScript exploitation from scratch live. And today we'll look at another primitive that is used in many exploitation scenario for browsers. We have seen addrof, which is the first interesting primitive. And today we'll look at the opposite one, which is fakeob. So if you haven't actually found the two faces in the picture, please do so. Spend a little bit of time and find the young woman and find the old woman too. And that's super important for today because this kind of duality will be really, really important to understand the concept of fake object. Okay, so if you weren't able to recognize our either young lady or old lady, I can actually give you some hints. Okay, so if you feel okay, if you can look, if you can see the old lady, it's just fine. Now I'm gonna help you. Here is the mouth, here is the eye, okay, and now you can rewire your brain. Okay, here is the nose. Okay, so this should be fine. Now you can see like the profile of the young, but you can also see the old lady here. Okay, so let's move on and let's just do a small recap on how data is represented within the JavaScript engine. So how pointers or non-values, like not a number, are represented. So you may have prepending 0, 0, 0 and then the value of the pointer. You may have a prepending 0, 0, 0, 1, which is 2 to the 48, and then you may have a double value. Or there are negative double values with FFFE, or you can have an integer, which is 32 bits on the lower 32 bits, and then you have FFFF 0, 0, 0, 0. Okay, so I also put some description here, which is coming directly from the documentation of WebKit, and I prepared like this scheme, which would help you actually to understand some stuff. And this is very important, like how the value are encoded, because it's all about encoding. Somehow these days, while I was preparing this class, I got like an understanding of how we are doing reinterpretation of values, as normally in binary exploitation you do code reuse. We are going to do like memory structure reuse in such a way that we could trigger somehow manipulation of values in an arbitrary way. Okay, so keep in mind that values are represented like differently, and we can have a quick look to the interpreter. So for example, if we create an object here, call it A, and then we describe it like this. So in the latest, the Docker image that I published, when I published the video, you have also the interactive. This is actually launched with the GDB, so you can do Ctrl+C, and we get this address, and you can inspect the memory with the usual suspect commands, and you can see that basically we have an empty object, and this is actually this value for C is the structure ID. Sorry, I should put something like this. Okay, 76, and basically if you continue and redo the describe 76. Yes, so that's the structure ID. Okay, yes, and this is a very important value, because structure IDs together with these other fields that you see here represent what is called a JS cell, and a JS cell somehow tells that the object may have some properties, it may have some values within. The things that we described in the previous video, it could be an array with double, an array with contiguous, an array with integers. So it's very important to have a proper structure ID, and we will see how this mechanism can be abused. Okay, so progressing on this, and now recapping for a second on the fake object. Instead of reading the address of an object as a double, which was the address of primitive, we could actually inject a double and make it read as a pointer. Okay, that's the gist of the fake object primitive. Now, the example is, you could see a young and fresh array of int 64 or a wise and old array of contiguous. And that's a little bit how this primitive would work. Okay, so first of all, I prepared a little bit of recap on C pointers. If you are not familiar with them, don't worry. There is a little bit of code that I have actually prepared to help you to understand this, because in reality, addrof and fake object really resemble the pointer notation, arithmetic, and whatever is possible to do in the C language. So you may have a pointer which is called p, which points to a value in memory, and it has an address, so it's possible to actually get to this. What I mean is to give you an idea, you may have a value in memory. Okay, just a second, that I have to enable my pen. Okay, and the idea is, okay, so this is cool because we have cells, we have the value 76 in here, and apparently this is just a value in memory. So how would you actually reach this value? It could be through a pointer, int star p, which points to this memory cell, and int star p may have the address of 41 and contains the value of 76. Okay, so it represents the address where you can find a specific value. Now in C particularly, you could do an assignment like this, and you would change where this is actually pointing. So imagine this is an array of integers, and then you have 81. So you could say p equal p plus plus, which means move one integer, because this is an int star. So now if you look at the value of p, which is like this, it would actually give you back the value 81. Okay, sorry, this was like an asterisk. Okay, so how to look at the value and how to actually do the assignment. And also you could actually assign the value to a variable which is an int p variable, and you could get, for example, the value of p right now, and b would be 81. So these kind of exchanges are completely legal in C, and somehow that's it. That is the first kind of primitive that we have with addrof and fake object. The possibility either to read an address, which, for example, could also be used the ampersand sign, and the ampersand of b would give us the address of this variable in memory, which then contains the value 81. And this address is completely different than the address of p, just a copy. Okay, when you do this assignment, b equals 81, you are just doing a copy of the value, like b equals star p, which is the value of p. You are in reality copying it. Okay, so to recap, okay, when you have an int star, you have a memory address that can hold value. It will hold an address. It will point to a memory cell. So an int star or a char star points to a memory cell, and the value of the pointer is just an address. Then you could have variables which contains a value, and variable 2 have an address, and you can just get them with the ampersand, okay, which is like using address of. Or you can actually manipulate the pointer by putting it inside a new address, and that's a kind of fake object idea, okay. I try to do this translation because then you can have a proper map in your mind, which is very, very simple as possible, because in C you have like either fixed types or pointer to fixed types. You know, you don't have that spurious types such as an array that contains doubles, ints, strings, and objects all together. So once we understand this, I want you actually to give you an idea of this code, how it could look like. Okay, so imagine we have a vector of 4 elements, is a vector of integers, so it contains 41, 42, 43, 44, A, B, C, D in ASCII. Then you have a pointer, P. And for example, in this case, P would get the address of the first element. Okay, and by using the ampersand and the array notation, because if you remove the ampersand, A0 points to the value of the first element of the array, and then you would print it. And that's the idea on how you could use the fake object, though within this parenthesis you would have a double number. We are augmenting P by the value 1, and the idea is that you are moving the cursor through the array. So I prepared actually a nice demo on Godbolt, which is here. Okay, let me just zoom in and just collapse a little bit this, which is not really useful. Okay, so here you have your array, the pointer, the value, then we are printing it, and then we manipulate. We can add 1, 2, or 3. So let's, for example, look at the element 2. Okay, this just compiled, so it says this is line 9, printf, the value of the first element is 65, which is 41 in X. We could actually make it look better, so we don't have to translate. Okay, so 41, 41. And the address of that element is this number, 368C EC40. Then we do a manipulation of the pointer. This should be the fake object, okay, while this is the address of. Okay, it's very simplistic, and it doesn't imply we have a jitter in place and all that kind of stuff. So it basically looks very straightforward. And this is a kind of fake object because we are really overwriting the value of the pointer. We are doing it legally in C because C is a low-level language, so you can manipulate memory the way you actually like. What I mean is that you can decide to look at this array as a double and print it out and see whatever value comes out, and no one is going to complain if you do the right casting. I'm not saying this is a good idea, but I'm saying that C, since it's low level and exposed almost all the interfaces of the machine without a lot of control, you can do really a lot of stuff, and that is why I'm going like to tell you how you do really do fake object, which is you are manipulating a value. Right now the value P is somehow intrinsical. What I mean is that I'm not getting the value back, manipulating it manually, and then adding some values. But you see that the idea is we are moving through the array by using this. By using this. Now, what is the value of having these two primitives is extremely important, because basically these two primitives will allow you to do something like this. Okay, so you can get the address of an object, which is fine. I mean, we know this address will give you a double number. Okay, and this double number can be converted into an address back and forth, so you know where a particular object is in memory. Now I'm telling you that I can also do something else, which is I can basically say the variable a is a fake object, and I pass here a double value, which means look at this address somewhere here and start to try to interpret it as an object, which is wrong, of course, because we will have the power to craft it. Okay, that's the idea. The idea is we would manipulate the JavaScript interpreter memory to actually obtain a valid object from a wrong memory that we have crafted on purpose. Okay, and the way we actually get into this point has some quirks, which means we have to do some spraying, we have to replicate the structure ID, because the structure ID actually replicates the number of properties that the object has. So we will be able basically to get the same properties, even though the memory that points to this object A is not an object that the interpreter has crafted, but an object that we have crafted. Okay, so now we enter into this concept of butterfly and the importance of dynamic arrays. Okay, so in order to understand this concept and why the butterfly pointer actually stands more or less in the middle between the values and the properties of an object, let's actually try to create a new object here. We'll call it Z, and we describe it. It has a null, for now, butterfly pointer, which means the butterfly pointer is right after this pointer in memory. Okay, so if we do control, let me just copy this and interrupt, for example, 6 hexadecimal addresses after the object, that's the butterfly. Okay, for now it doesn't contain anything, so let's try to do something like this. 1, then B will get the value 2, then C, it will get the value 3, and then we try describe again. The butterfly is still null. Then let's try to add something like okay, so there is a moment where we expand the number of elements, the types, that the butterfly may actually get a value. It really depends a little bit on the size. And we could actually do this because we generated an empty object, but we could do something like this, like we could basically do the following. Instead of creating an empty object, we can start with an array, and the array would actually have already a butterfly pointer. And then when you're actually adding elements, as we did like this, the butterfly may change position. Okay, so the idea here is when we add some elements, there is something happening in memory, which is the object is increasing size. Okay, and before I go to the next slide, let's actually explore for a second this object. Okay, so this is the butterfly pointer. This is the structure ID. There is a slide afterwards that would help you actually to recognize the structure ID and what actually are these upper bits in here, which help basically the interpreter to understand what kind of structure is this. Now let's look at the butterfly. Okay, so the butterfly from this point on contains the values 1, 2, 3, which is, if you look at the interpreter actually, and you look at what we did, so 1, 2, 3, 5, then there is the value null, which is encoded in a specific way that we will see later. And then what I actually want to do is let's look for a second before the butterfly. So for example, so you see that if we start before, we have here this pointer that actually is telling us that the structure has 5 elements, 5 properties. So the array has 5 elements, and here we have properties that are starting. So this is a pointer, and it could actually contain different information about this JavaScript construct, which is our object Z. Okay, so what happens is basically when you reach a certain threshold, a new butterfly would be allocated because your number of values or number of properties are actually increasing. And somehow, I mean, this is not a direct mapping or usage of realloc, but if you look at the realloc call in C, if you realloc an existing pointer and you actually make it bigger of a certain size, it may return a different pointer, which is exactly what is happening here with the butterfly. So the butterfly is used actually to somehow to smartly reallocate our structure if it's growing. Okay, because the idea here is that when you are actually executing JavaScript, you know that your object may grow dynamically. You may append stuff here and there, and basically that's the idea, right? If you try to append stuff here and there, it will grow and it will change. So you'll have these two constructs, while the basic structure idea of the object will remain constant because this address will not change. So if you look at the memory address of this, let me just reuse for, okay, so this will not change. This contains the structure identifier, and the one that may change is the butterfly pointer, and this will help us basically to change dynamically how this object contains new values, it changes over time, and whatnot. Okay, so this is kind of a preamble to understand how the objects are actually structured in JavaScript. What I mean is that, to recap, when you have a new object, let's call it A and let's put it empty for now, you will have a pointer to the object, then there will be a butterfly. This is 64 bits. Okay, and then you may have the values And eventually, if this object has properties like A, like B, like C, they may be before these others, so up here, okay? And that's very important to keep in mind this structure, because it's what we will actually try to pollute and change, okay? Okay, so now let's try to, starting from addrof, let's try actually to retype and rewrite our fake object by using some logic. Nonetheless, I have already rewritten, but I think it's a nice exercise. Okay, so we have here the addrof, and let me just use some syntax highlighting, otherwise we get a little bit blind. Okay, so remember that we have a double value. We use that trick of the regular expression, and the regular expression triggers a bug because it uses the last index and the sticky regex pattern, which basically means start from the last index, and normally the last index is an integer which is pointing to a position of the string, but in this case it is basically a function, and this actually fools a little bit our jitter, because if this happens to execute enough times, it will basically leak the address of the first element. Okay, so you are asking here, you normally give here to the address of the identifier of an object, and what is happening is basically that you'll get returned by this bug this pointer, this one. Okay, instead of giving you that is an object and just telling you, okay, you have an object, which is a syntax that you may see here, right? When you create a new object and you do something like, let's use another identifier. So if the interpreter is not buggy, you get this output. But then if addrof is well implemented, and you give the object, you'll get this. And as we actually know, if we pass this to our address unpacker, you'll get this, which actually corresponds to describe of k. Okay, so here it is. Okay, so we are actually triggering this this vulnerability, because the idea is that we have a sticky regex, but there is a function, so the interpreter somehow gets confused. It cannot interpret the last index as a number, so it actually converts, it resorts to the double type, and it returns the pointer to the object as a double. Okay, so how would we actually write down the opposite of this? Okay, so let's try to make the exercise, and let's go down here, create some new space for us, and let's reason about it for a second. Okay, we know it's exactly the same vulnerability, the same idea, the same concept. Okay, so now we need to think for a second, because this was actually described by the article of Sailo on Frac. So if it behaves the other way around, we should basically give it a double, and it should basically write an hexadecimal address. Okay, of course the function should be called something like address setter. Sorry, so let's start to change this, and let's start to change val to actually be to actually be our double value. And here also this needs to change. And just give me 1 second. Let's start to reason. Okay, so now instead of actually doing this, what we should actually do is we should set the double value into the first position of the array. Okay, let me remove the return for now because it's not really needed. Okay, so now remember what we are doing is instead of reading this value, we are just writing this value. Okay, but there is a catch. Instead of reading this value, we are writing it, and the catch is, hey, this value actually is a structure of an object, and this is a pointer that normally should actually tell us that we are pointing to a legal, well-formed JavaScript object. Okay, so the idea here is that we will basically override this and trigger the same idea, the same concept. Okay, so let me just check exactly how I did it, because I mean, so you see that we are basically assigning it as I actually mentioned, and then there is one thing that is here. Instead of doing this assignment, what we will do is we will actually push a fake object here, sorry, an empty object. Okay, and basically that's it. Now we should return the first value, which contains, so we call the address setter. This would actually overwrite it, and now we return it. Okay, so just a second, because this is tricky. What is doing this return on line 77 is actually shadowing this process. Okay, if I do L equal, okay, this means I am creating a new object. It will automatically give it a pointer, a structure, a header, blah blah blah. Okay, now the deal is with FakeObj, what we will do is, by actually providing a pointer, by actually providing a double value to the function FakeObj, so I can actually show you. We will basically try to get a valid pointer to an object if whatever is pointed at this address, which is encoded in double, but we know for the logic of the non-encoding. Okay, let me just reuse. That this is possibly a valid address, and if it contains all the data, which is basically correctly crafted, it will basically return a valid object. Okay, so right here, and how are you doing? Are you following? Do you feel lost? Because now we will try to actually manipulate an object through these primitives. Okay, so any doubts, any questions? Okay, so well, I mean, in this interpreter here, I already have the primitives. There is one thing that you need to know that actually happened. So if you launch it like as a separate interpreter without the debugger, the addrof primitive here, I think has a loop of 10,000, but with 10,000 you don't get the vulnerability out. I needed to give like 100,000 in order to get the address. Same thing for the fake object, for at least to have the debugger working on it. Okay, so we have both primitives. One is capable of writing an address and one is capable of reading out an address. Okay, so now there is also another, like somehow call it foo or technique that we can use, which is this kind of idea. In order basically to be sure that we want to fake an object, okay, I don't know what is going on, but I was just typing something. So imagine we have this object which is called test, okay, and test has a property. So let me just check. Okay, there is already this test object, and it may have a property which is x, okay, which is set to 1. Okay, so if we describe test and we get the address, so we know that the value is here and this is the structure ID. Okay, you see that the structure ID is pretty high, and the reason why we do this is that we are creating a lot of fake structures in order to be sure that we will not actually fail when we are crafting a new structure. Okay, so quick recap, and let me go for a second into this. Okay, so what does it mean is I'm going to create an object which I call test, that I want basically to replicate in memory or reuse because it has a particular property. Okay, for now let's forget about the type and whatnot. Let's just think the test as an X property which I can set to a value. Okay, so remember this object as a structure in memory. It will contain here a pointer, here the butterfly, and here the values. And before the butterfly you may have properties. Okay, so what happens is, if we want actually to use properly the FakeObj, as a first example, if we get the address of test, we could get a valid pointer to the test object without really doing anything. And let's actually start with that because I think it's the fastest idea. Okay, so let's create a brand new object, and we call it brand new. Okay, so if I do address of brand new, I get this double value. Okay, and now what if I want to create a copy of brand new, and I actually give this pointer? Okay, so now this means when you get this kind of response, it means the fake object primitive didn't work because it should return object. Okay, this assignment should return an object, which means that we should possibly reshoot it, okay, to the interpreter, which is good. And let me just tweak it. I actually have it here. So you see that there is 100,000. The function is not really different than whatever we have changed it. Okay, but let's reshoot it to the interpreter. And now if I copy this and say copy of brand new, we get an object. So brand new now is a shadow copy of our brand new. What I mean is that, sorry, this got weird. Okay, so if I do brand new dot x equal 999 and then I say copy of brand new dot x, I get the same value. So through fake object I overlapped an object structure that is called copy of brand new and is basically pointing to the same object. I mean, this seems useless for now, but it's like the first dumb example of using fake object. Okay, now the idea is a little bit different, and it could be we could create an object and then we can manipulate it to reinterpret it as our brand new, for example, without actually using the describe function. What I mean is that you have seen that right now by creating brand new, using address of, and then using fake object, I never logged into the GDB. I never looked into memory. I just used transparently this, because remember the describe function is not available in the browser. So it's just available because this is a debugging mode of the interpreter. Okay, so if we do describe of brand new or copy of brand new, I mean, they will actually be, sorry, copy of, they will actually be the same because they are just two pointers. Okay, they are just two pointers to the same memory area. Okay, the good thing about fake object is that no one can block us to actually put whatever double value we want into the fake object call. Okay, so what if I put in here whatever double value? Then I get a reference to an object that I can manipulate the way I would like. Okay, is that starting to make sense? Do you understand now how powerful is this? Because this fake object will give me back a reference to a memory area, and if I'm able actually to craft honestly the structure ID with the properties that are actually part of that object, then I will be able to manipulate an object that I'm not supposed to access. Because now, remember that the value that we put within the parentheses of fake object can be any memory address of the JavaScript interpreter. So this is actually dangerous somehow, because we could modify the value of existing objects or craft specific casts, and that's how I would call it, to actually reinterpret some value and change them. Okay, so let's actually try this this example. Okay, so and what I'm going to do is let's create a target object to actually keep in mind the structure that we are going to define here, even though target will be just an example for now. Okay, so we have an empty object, and you need to actually keep in mind these three properties that we are going to set with these very verbose names. So you will have here the first property, we will call it fake structure ID. The second, I mean, let's actually put it like a value. So the second will be a fake butterfly. We give another value, and actually the third will be a pointer to a property we want to control. I mean, this is just very verbose because I want you to get the idea of the fake object we are going to create. Okay, so remember, now we have put 1, 2, 3, and if I do describe of target, and we are within the debugger, so I do Control C and I get the address of target, and I do x/6gx, you'll get our target object is basically starting at the address 080. This is the original structure ID, this is the original butterfly, and these three elements are actually elements that we would use. So these are the three properties we have set. So the fake structure ID, the fake butterfly, and the pointer to the value, to the property that we want to control. Okay, so far we have just created an object. In this case, target is just an abstraction that I want you to memorize, because we would use these three slots, okay, to actually prepare a fake object in memory. The JavaScript interpreter actually right now knows that an object boundary starts at 080, but after our manipulation and the proper usage of FakeObj, we will actually make an object, we will craft an object at our own disposal with our own structure ID that would be basically crafted by using these three properties that I have highlighted. And let's now make sure we would have plenty of structure IDs by using this spraying method. So you have a for, and this for loop is very big. It's almost 10,000 in decimal, 0x2000, and it creates a test object with a property x, and it also puts some extra property in here. Okay, so now we are really plenty of structure IDs, which means that you see that this structure IDs is very high, and the structure IDs are sequential when you allocate new structures in the JavaScript interpreter, new object, sorry. So now if we actually go into the debugger and we get here the address, you will see that we got here very high structure ID, empty butterfly, the value of x, and the value of the property numbered whatever, depending on the iteration of the loop. Okay, so this value is very interesting because it will be consistent among all the object tests that we have sprayed into memory. Okay, because besides the structure ID, which is this last part, the flags would actually contain data that would say this is an object that has one property which is which looks like an integer, and another one which is named by a string. So this kind of data is encoded into this value. So let's actually copy it, and now let's start to use our primitives addrof and fakeObj. Right now we have actually already sprayed the test objects around, and now we would use basically this kind of this is the same as the target object, but we would use a more synthetic notation. So fake.a would actually hold a double value, which is the fake structure ID, and we have to actually get it properly. So this would contain a double representation of the value that was actually represented in here. Okay, just to give you like an idea on how it would look like. Okay, let's for now just set a double value like this one. Okay, then we have the second property, which, don't forget, is the fake butterfly. Here again we could give a random value, and then we have fake.c, which is the pointer to the property that we want to control, 1337. Okay, so now by having stored this value, which is the value of the structure ID, what we would do is we would use our translators, so the address packer, that would give us a double value. Okay, so according to the explanation, fake.a now should hold in hexadecimal this value. Look at it, 0x010016. Okay, so now if I actually do a quick describe of fake, and the reason why I'm doing this is that I explained you that the JavaScript interpreter uses an unencoding, which means not a number encoding, and it has some quirks when it's treating with doubles. So if I stop and I actually try to look at the memory here, where the fake object is, and the property A is right here, and it looks slightly different than the value we have plugged in, because it looks like 010116 while we provided 010016. So there is a 1 here which actually corresponds to the number, to the hexadecimal number, to the 48, which is actually how doubles are encoded. So if you want actually to replicate properly the address in memory, we need to subtract to the original address, we need to subtract the hexadecimal value of 2 to the 38 to the 48, sorry. So here we should put a minus and reduce the number slightly. Okay, so now we go back to the interpreter, and we reset fake.a to this value. The interpreter is going to add 2 to the 48. So now if I go back to the debugger and the address hasn't changed, right now we have 010016 plus the structure ID of an object that we know is the test object. Okay, and if you actually have lost the thread for a second, let's just describe test, go back into the debugger and look at the structure ID. Sorry, small mistake. We need the address of test, which is here. And you see that the structure ID actually looks like this number, which now has a curious representation because it is somehow starting at 0x10, so 16 bytes from the address of fake, from the starting point of fake. Why do we want it to do this? It's because we want to craft an object that is capable of actually owning a property that otherwise we would not be able to control. There is one another thing that we have actually to check at. Normal objects in when they are just created, okay, so For example, this is our fake object, because you see this is the structure ID, this is the butterfly is null. While here, where we are trying to actually create our fake object, there is this value which is 0xFFF that I set as fake.b. So now, in order to get a null pointer here as 0, because it's our fake butterfly, don't forget about the target object that we designed at the beginning as an example, as an abstraction. So there is a very clever way, which is delete. If I delete fake.b and I then go back into my debugger, I got here a null pointer. So now, starting from this address, we have a reproduction of an object that otherwise would not exist, because it's true that at E0 you have the property C of the object fake, but if you actually make the fakeObj function point to this address, you'll see the magic that would happen. So now we know what is the address of fake, and we know there is an offset of 0x10, 16 bytes, where our raw data that would be interpreted as an object would start. So let's actually make sure our interpreter contains the proper fake object and address of primitives. So I'm just trying here, just repasting them in order to have them ready, and we get address of fake. Address of fake returns a double value, and we know that this double value needs to be first changed into an hexadecimal, which is this one. Okay, so you get this number, and this corresponds to the address of fake, but then we need to re-encode it as a double plus the offset of 16 bytes, because that's where our raw data is starting. So this number now is the number that we want to store via fake object. What do I mean is, now this is a pointer to a fake object, or better, I would not say fake, but more forged. A pointer to a forged object, okay, and we call FakeObj, and we give this value, which, remember, is pointing 16 bytes after the starting point of fake. Now we got the address of fake, and then we actually made some calculations here to get to the offset that we want. So to recap for a second, remember that the fake object contains the first 16 bytes to be the structure ID and the butterfly. We have actually sprayed here a test object with the property X that is sprayed, so we have a lot of structure IDs that we can actually control. I set already the structure ID in property A of fake.a, then I set the butterfly to a number, and I deleted it to obtain a 0, because with the non-encoding it's the only way to obtain a 0. And then I set the property C, that is the property we want to get in control through the forged pointer. So if now we go to the interpreter and we use fake object, and the primitive has been correctly interpreted, and somehow the jitter triggered the vulnerability, we would get an object. So here you see that pointer to forged object is actually a valid forged object that is starting from an offset that is actually skewed from the original fake object. So we are here, you see, fake.a, we basically got an object starting from property A of fake, which was recognized correctly by the interpreter. So now, since we have inherited a structure ID which comes from test, the funny thing is that our object, which is called pointer to forged object, contains a property X, which has the value 1337 that you know was actually the value of fake.c, which was the third property of the object C, which is actually the property we want to get in control with the forged pointer. So why it's X? Because X is the property of the object test of the one we actually reduced the structure ID. So our interpreter is somehow putting a cast around the address we provide via a double, and is saying I'm interpreting with this structure ID and butterfly that has a particular property X. And of course our forged pointer would also have another property such as this one, which we can also control and modify. So that's successful object forging through the usage of two primitives, addrof and fakeObj, that actually enable us to forge data in memory and make it interpret from the JavaScript interpreter as a valid object. Recapping after the demo, we have seen that our JavaScript object have like a JSL header, which is 64 bits, 8 bytes, that contains the structure ID. You see from the least significant bit, and then it contains some flags that would basically help to recognize the structure. And that's how we have crafted the example in memory. The actually address of the forged object is 890 and the address of fake is 880. So this is how we basically have used an object ID that was already existing, which is this one, plus nullified a second field, which is the one that was representing the butterfly, and got in control of a property which was already set by the fake pointer, which was fake.c, but in reality we control it with the name, with the mnemonic X, which is pertaining to the test object. And that's how you would basically step and continue to actually achieve arbitrary read and write of memory, because through this mechanism, if you think about it, addrof is actually capable of reading a particular object and giving you back the address, and this one actually allowed us to put a cast around a memory area that otherwise was recognized as properties of another object starting at 880, but we actually used FakeObj to craft a new object starting here just right after the JavaScript header and the butterfly. Forging objects is something that at this level of control is very unique and very powerful, because if you believe you can create objects with the JavaScript interpreter, that's actually true, and that's completely fine, but you cannot really control their structure, you cannot really control the way they are formed. So somehow the addrof and the fakeObj primitive, what they do allow is minting JavaScript object with memory that we control 100%. So with a little bit of tricks, we are able either to cast memory in a particular way or to modify it to our own desire. And that is basically the power of this primitive. So I would say that that's all for this class, and I want to say thank you. We have had actually a great journey into the fakeObj primitive. We have actually seen how to craft an object from a rogue memory that we control, somehow doing memory reuse as a structure ID reuse as our fake object that allows us to basically control a property X of an object that otherwise would not exist. Thank you very much for this second episode of our JavaScript exploitation from scratch, and see you into the next one.